Hello everyone, and welcome to today's Energy Storage News and PV Tech webinar, From Risk to Resilience, Enhancing Safety in Battery Energy Storage Systems with Trina Storage. And it's an especially warm welcome from us today, as this is our first webinar of 2025. Happy New Year, and we wish you all a successful year ahead. My name's Andy Colthorpe. I'm the editor of Energy Storage News and deputy editor-in-chief at Solar Media, the publisher of PV Tech and Energy Storage News. On ESN, we publish an annual year in review series of articles, looking back on the 12 months and ahead to the next year every January. We ask some of our contacts for their views on the trends and topics that are shaping energy storage. And it always includes a question on what they believe the industry's priorities should be for the year ahead. This year, as with most previous years, almost all of our interviewees have said that safety should be among the top priorities, if not number one. And while battery storage system fires are increasingly rare, and codes, standards, and industry best practices are evolving, if something does happen, as one source told me a little while ago, when one battery storage system has a fire, it's everyone in the industry's problem. We've all seen the news reports of energy storage projects that can't get local authority approval because the community that lives there has a certain perception of the safety risk posed. And of course, from a business perspective, fires can be costly and damaging across single projects and whole portfolios. On a different note, it's also really fascinating to see how technologies and standards are being adapted to both prevent fires and minimize the impacts of even a worst case scenario. And that's where today's expert speakers come in. We're excited that Hakeem Dairo, Trina Storage's product manager for BESS, will be joined by a special guest, Shimeng Wei, Vice President of Renewables covering solar PV, BESS and power conversion systems at TUV Nord. Hakeem can give us an industry viewpoint, updating us on the tech and strategies Trina Storage is bringing to the market, and Shimeng will show us what the standards and codes are that BESS providers must meet and offer a roadmap to planning a successful project. As always, interaction with you, the audience, is really important to us. So please put your questions for the speakers into the questions tab that you can see on the right-hand side of your screen. We can't promise that we'll answer every question that comes in within the time that we have allotted, but we'll do our best to get through a few of them. And rest assured that all the other questions, Trina Storage will be more than happy to continue those conversations offline after the session. And finally, one last bit of housekeeping from me. This session will be recorded and slides will be sent out to registrants, and it will be available to view again on demand on the Energy Storage News website and on the Energy Storage News and PV Tech YouTube channels. So with that, and without further ado, it's my great pleasure to hand over to our first speaker, Hakeem Dairo. Hi, Hakeem, it's over to you.
Hi, Andy. Thank you so much for the introduction. And welcome to all the attendees for the webinar today. Thanks so much for joining us. It will be my pleasure to take you through what we do at Trina, some of our features, our product features, and how we see the battery market, some of the challenges we face, and how we intend to satisfy our customer requirements going forward. My name's Hakeem Dairo. As Andy has said, I'm a product manager at Trina Storage, and I primarily look after sort of the UK, EU markets, even though Trina does operate in several markets globally. My background is very much in engineering, and I'm an electrical engineer by background, and I have been in the batteries world for quite some time, starting from automotive industry before moving into sort of utility scale battery design and manufacturing. So really pleased to be here to talk you through what we do at Trina. Without sort of further ado or waste any more time, I'll jump straight into the next section, which is looking at some of the challenges we face as a manufacturer in the battery industry, in essence. Obviously, today we are primarily focused on safety. We are talking about safety, but as a lot of attendees on the webinar would probably have an idea of, there are several challenges faced by the industry more generally. If I look at the first column, one thing is cost. So project cost, product cost, project lifecycle costs. Uh, Cost is always a big factor that matters to customers, to investors, to operators, to asset owners. It's a big thing that we try to bring down as much as possible to allow our customers specify their projects better and gain the confidence with investors that it's going to pay off in the end. For us, what does this mean? We want to design battery systems right from the cell level, which can meet its performance targets over the life of the operation of the part. We want to, and this can be broken into sort of several different parts, which is looking at the electrical performance of the entire system and the thermal performance of the entire system. As you'd imagine, these factors can significantly have significant impact on the end project or where it's being applied. We want to bring the levelized cost of storage as low as possible. In today's world, lithium ion is as cheap as it has ever been. So for sure, as a manufacturer, we are trying to ride that wave and make the best product possible. Secondly, we think of environmental and logistics challenges or issues ranging from installation times, having broken out components or broken out or segregated components while shipping to site to build or assemble a system. You talk about noise, you talk about any toxic emissions that could come from materials used in battery design. All of these factors matter to a planner. They matter to an AHA. And these are all factors that need to be considered before we install on site. What is the noise profile of our system? How does it look when you install it? How does it look when you service and operate it? These are all considerations for us that present a massive challenge to us as an OEM. And then I guess finally, what we're all here for today really is this is the third arm I would say we want to focus on, which is safety. And that is promoting safety in all aspects of product, project, and site development. For us, it means having extensive, detailed risk assessments on the products and our manufacturing processes, ensuring we get the cell quality right, and I'll talk about that later, and overall system design. So have we designed a system that is operating electrically correctly, operating thermally correctly, because these all have an effect on your entire project lifetime. Several studies have been conducted, and there might be some. Don't want to say too many names, but there's been interesting conversations about the benefits you can gain if you have this amount of thermal performance versus this amount, a lot of electrical performance versus this amount, and all of these studies will conclude that there are significant savings to be had the better your system performs. So this is very much something we consider from a manufacturer perspective. Sticking with the theme of safety and very much staying with the theme and staying focused on here. I think Andy mentioned earlier during the introduction that we are having, there are safety incidents that happen, but as you can see from the chart, we are installing a lot more batteries than we used to. So obviously, more batteries, more sample size, there's high chance of having more incidents. But this is a lower proportion to what is to the total installation, which is a good thing because it means we're installing more of these systems and we're getting less incidents. A lot of the incidents people might have read about or seen on TV or whatever. Several of these events actually happened prior to development or updates to several regulations. We use the NFPA standards, the Underwriters Laboratories Safety Series, These are all things that have developed following safety incidents. So we have an issue, again, as Andy correctly said, any issue with anyone, it doesn't matter the supplier, it doesn't matter who's like my competitors or any of that. It's a problem for all of us. So we want to see reduced incidents. We want to promote the safest systems we can to the customer. For us, when you install these systems, we are having less and less safety incidents. Looking at the second chart, just to point you towards the second chart, what we found is several of these incidents have actually happened within the first sort of 3 years of installation, which certainly draws an interesting sort of thinking, which is from my experience and my knowledge of incidents or safety incidents that have happened in the past. Several of them have, I will always say we design batteries as safely as we can. We are continually improving them. But several of these events have actually been triggered externally. What does this mean? It means we've had an incident that's, or a safety, or a failure, I will say, on one side that's carried or impacted the battery system. Um, it's not always the case. In fact, it's less so the case that it would be an internal failure or your battery is operating normally and then something goes wrong. From a battery perspective or from a manufacturer perspective, getting the cell quality is absolutely right. Is absolutely critical because you get the cell quality right. You don't have defects that end up materializing on site as they have. You looking at that second chart, a lot of those incidents in the sort of first year, um, speculatively, a lot of times for the incidents that have had a defect, so usually when it's a DC battery problem, it's usually a defect that's happened in manufacturing, just emphasizing how important it is to get your quality right and to get your risk assessments right. And Shimeng is going to talk more about the risk assessment process later. But so those zero to the first year, a lot of instances like that, you will have defects in the battery that materialize in year two, year three, speculatively thinking these are incidents that could have external impact. Just thinking about some events that have happened, not naming any names, but if I think of the top five events that come to mind, one of them was, yes, a defect internally. Another was very bad thunderstorms, very challenging environment, led to um, the enclosure failing, leaks happening and shorts happening within the enclosures that then led to a fire. Just as an example, that just highlights the importance of the verification processes we go through, which I'm going to talk about later as well. And another third arm, so it's the internal cell failure, external impact, and finally another external impact, which was AC fault happening and being carried over into the battery that led to a battery failure that then caused an incident. Again, external impact just highlights the importance of verification and having site-specific, project-specific plans that meet your safety requirements because these can happen. So we need to have systems that can open up the circuit or close the circuit accordingly whenever there's an incident detected on one side. We want to reduce the carryover of failures from one side to the other. So the takeaway from this, guys, is we have a lot more installations. We have some more incidents, less proportion of the total installation, and we are continually working. And with the development of the certifications, the regulations, the rules we have to follow as design, and our own ambition to do better than what is absolutely required, will continue to improve the safety of this. Batteries are no more worse offending than other equipment we've been operating for a very long time. You know, NFPA did a study in 2023 that concluded batteries have generally see less events than things like transformers on site or switchgear, all of these things. So it's definitely an important thing to consider. And for us, it's a priority. It's something we absolutely focus on all the time. Just to add as an add-on to the previous slide, just talking about, and I think I've already alluded to a few of these, is looking at the root cause of some of this. Making sure your product is intrinsically safe. So designing a system without defects, designing a system that doesn't have any issues internally that could lead to issues externally. Having quality management system that's able to detect any issues, any problems before we get to a point where we're shipping a product to site or to a project. It's very important. And finally, as I mentioned earlier, the verification process. After making or assembling a quality product, could be a cell, could be a module, could be a cabinet, we have to go through detailed verification processes, adhering to standards defined by the industry, standards defined internally through our engineering teams. We try to make sure we evaluate according to these to make sure we're able to deliver the best product at the end of it. So very, very critical, very, very important to have all of these processes in line. Aside from, yes, we know how to design a system or we know how to design this, we need to have the verification, the quality tracking, absolutely bolted onto that to make sure we're able to make the best product ever. Just to add some more, I think I'll hand over to Shimeng now from TUV to talk more about the risk process and how that's developed.
Thanks, Hakeem. Hello, everyone. So my name is Shimeng Wei from TUV North. I'm the expert for the battery and energy storage systems. So today I am very honored to be invited by Trina Storage for this webinar and can share our view and our experience with regard to the battery energy storage systems. So in this part, as Hakeem mentioned, I will discuss about the risk analysis of a energy storage system. So when we always talk about the safety of the energy storage system, but how could we make a comprehensive evaluation of the risks and how can we make sure the risk is reduced and we have a safe battery energy storage system? So on the screen, you can see the workflow, how we should do a very comprehensive analysis to do the risk analysis for the energy storage system. And we start with identification of the hazards. So the hazards is the damages could be done to the people and to the environment, and that could cause you a loss in the money or in your health. And that's why for the battery storage system, we start with identifications, what could do the damage to the people and to the environment. So the risk is actually a combination of the possibility that a hazard could happen, and also it is the severity of the hazard, that when it happens, how big the damage could be. So when we know the hazard, we should do an estimation of the risks that to understand the severity and also to understand the possibility of the hazard. And after that, we do the evaluation of the risk to see to what degree we can help and we can solve the risk and to reduce the risk to a certain level. So when we find a good solution to make the reduction of the risk, we should make the estimation that after we did what we plan to do, all the preventive and protective measurements we did, what would be the residual risk after we did all these things. And we also need to evaluate the residual risk and to see if it is acceptable for us that the risk is low enough and to make the battery storage system safe enough. And in the end, we do the validation by testing, by design review, by all the others, and we make a good documentation. So here is a closed loop, how we can do this risk analysis. So for the battery storage system, which is a combination of high voltage, of heavy machinery things, and the possibility of overheating, here are some examples or aspects that we should consider when we do the identification of the hazard. So such as electrical hazard, which is most of the time could cause electrical shock to the people, and also arc flash, which can lead to other potential hazards like fire. From the mechanical side, we should consider that since now the energy storage system is bigger and bigger, and each battery pack is also getting heavier and heavier. So the risk for like the drop of the battery pack that could also cause damage to the maintenance people, and also furthermore could also cause the explosion of the system. And we have the fire hazard as well, which is clearly on the way. And we have the temperature hazard. Either the temperature would be too high, that cause when people touching the battery pack, it cause some damage to you, or when it is too cold, then the system could also have the problem itself. When there could be explosion or fire happened, the chemical hazard comes out. That that we can see some gases would leak to the environment and therefore cause some severe damage to the people around. And we also have something that is not visible but always there, that magnetic and electromagnetic hazard, and also to the maintenance people, that the unsuitable working conditions could also cause problems with them. And the next step, as we just talked about, is the risk estimation, where we need to consider the risks that could happen. So there are something that I want to emphasize, because generally a battery energy storage system is quite new in the market. Therefore, something that is still not so perfect in the real world, such as safety policies, such as guidance and indications for extinguishing fires, evacuation plan, roads, and indications. So these are something that will have to be perfect during the time courses and have to be bear in mind aside with all the other considerations. With regard to the evaluation method, there are some systematic methods could be applied. Nothing is good or bad, but just to depends on the hazard or depends on the risk we want to analyze. Different methods could be used. So when we categorize these, we can use the bottom-up first principle risk analysis, such as FMEA, and also other ways like fault tree analyze FTA, such as top-down analyze, and also some combined or integrated analyze, such as HAZOP methods. And in the end, we need to take some measures to reduce the risk. So there are generally two categories for that. One is preventive measurements, and the other way is protective measurements. So the preventive is kind of when you do the design that you can already start to make sure the risk is prevented, and then protective is like the safeguard when the preventive measures is not working or has some problems. Then you still have a second layer who could still protect and reduce the risks. So this is there's one particular thing I also want to mention. It's about the operation and the maintenance. That in the market actually is also not as the battery energy storage system is still new, and then the experience for operation and maintenance work is still need to be perfected during the time courses. Okay, so I will give back the floor to Hakeem and continue with the presentation. Thanks.
Thank you, Shimeng. So we've sort of talked about the general challenges we face. We've talked about safety, and we've talked about the risk assessment. And I think what we're just trying to highlight or pictures to show how much work needs to be done to actually achieve the safety goals we set, either at the start of product development or project development. With batteries, safety, yes, there's product safety, but there's a huge chunk of the overall safety plan that actually is attributed to the project. or to the site. And that's just one aspect that's also really important to consider aside from the product. So I'll jump straight into talking about our product, how we what we offer the market to try and alleviate some of these pains, and how that could work in your project or on site, based on what we've designed. We class safety, I'll say, consider safety into three sort of different aspects or pillars. It's not limited to this. There's a few other points, but generally, as firstly is the electrochemical safety. So getting the cell right, making sure it's stable, making sure we're trying to use the correct type of materials inside them, and we're not leading to anything that could cause a safety event. We have to be compliant to things like REACH, ROHS regulations in Europe, so it's always worth considering. Electrical safety, second aspect. So that's making sure we have done our short circuit calculations correctly. We've done our fusing and switch calculations correctly, to make sure we don't have arcing, we don't have fires, we don't have electrical safety events that could lead to damage or worse. And finally, mechanical safety. This is making sure that the mechanical enclosures we use in our systems are robust, are able to withstand some levels of stress. It could be mechanical, it could be thermal, some level of stress to actually satisfy the safety goal. As I mentioned earlier on, there's been events in the past, and this is just again trying to highlight how we've moved from how we learn our lessons from events. I talked about earlier. There was an event, not saying any names or anything, but what had happened was everything was operating normally, everything was operating fine, but there was a really bad thunderstorm. That thunderstorm seems to have breached the enclosure, which made it leak, and then obviously shorted sort of bus bars and modules inside the unit. So very, very important, all of these aspects, the electrical, mechanical, and thermal side, these are all key constituents of the safety sort of goal. And just looking into that, I would like to introduce our Elementa platform. This is Elementa 2. There might be some on the call who have an Elementa already, who have evaluated or looked to have one. And I just want to talk through some of what we have as key features that help promote the safety of it. Looking at the overall picture, we have the exhaust and intake vents on the Elementa, and we have pressure valve on the modules themselves. So on the modules, as you can see inside, so the module or the pack, sorry, it's labeled pack on the screen. We have a pressure valve in there, and then so that's a means for the module to breathe. I always say to breathe because before you go into an event, it will most likely release some gases. We want to let the module breathe and then eject any any flammable gases or any gases that are not supposed to be in there through the exhaust valve or through the intake valve. So and then sort of finally the specific components that make the overall fire suppression system. So that's considering the alarms, considering the dry pipe sprinkler system, considering the sensors that we have. Actually, I'll move to the next slide so I can show that. So that's the use of a water sprinkler system, dry pipe, heat detectors, smoke detectors, gas detectors, and the aerosol discharge in effect. And this would be a section or a page that everyone might have a different opinion on what's best in class, what's the best way to do it. And I can tell you, having been doing this and reading several books, it's very hard to we don't have one full consensus like this is the best way, but this is our understanding of making sure we're able to satisfy the requirements. I think one of the challenges generally is how we harmonize all of the different requirements for the different regions to allow us create the best product. But for the Elementa, as shown, I've listed the components, and what would typically happen is if we have all these sensors, we have all the detectors, primarily to make sure we are able to capture any abnormal situations at any time. We want more than one data point because there's going to be more than one indicator that you might have thermal runaway. What you might not know is thermal runaway doesn't always have a fire. You can have thermal runaway where you don't have open flames. So something to consider, because this is how this is the reaction of the batteries that we're trying to understand better, and we're trying to protect against delayed explosions, all of that sort of parameters. So we've got the smoke, heat, and gas detectors that would all trigger depending if their thresholds are met, or either excessive heat, excessive smoke, or excessive gas detection. And then the elementer triggers, the BMS triggers actions. So actions of either opening the vents to release some gases, or worst case scenario, triggering a level 2, which would be, right, I want to shut down the system. I talked earlier on about one of the battery events we've had, or incidents we've had in the past, was fault transfer from AC to DC. Well, if your battery is able to react very quickly to faults, detect, the BMS is able to coordinate very well with the EMS, detect any issues, you can open the circuit and again protect the battery. So for us, if you get to a level 2 situation, for example, on any of these data points, it will lead to a yes, it needs to stop now. Someone needs to check it again to make sure none of these events get carried over or going beyond where they need to. So we have all of these, and if necessary, as and when required, an aerosol might be discharged. And then finally, the water sort of dry pipe sprinkler system. We don't want water continually flowing in an electrically live unit, but it is there as an additional level of mitigation to any event. So if you've got first responders that come on site, they can connect up to the elementer to release some water to the sprinkler system. What we've done, or what we've designed, as indicated on the slide, is all NFPA compliant. Maybe one thing to mention here, for those that might be really looking at this system as an option, is something that we're hearing more of is the use of deflagration panels, and we do offer those as an option, as and when required. Again, varying requirements in different regions sometimes can be quite a challenge, and it's something for us as a manufacturer that we need to absolutely keep up with. But yes, so this is sort of our understanding of what an FSS system should look like, how it's going to perform, and to date we don't have any incidents, so that's a good sign. So I think that's probably it on the product. Several little features, but these are sort of the key ones to talk about, and we can talk about any further details at a later point, maybe through questions. I would now like to talk about sort of some of the standards and the validation we do, again, just to highlight and promote the fact that safety is a big consideration for us, and we try to meet our safety goals as diligently as possible. But before I jump straight into that, I will hand over again to Shimeng to just talk about some of the standards that TUV have been looking at from a battery perspective.
Okay, thank you, Hakeem, again. So Gemini as a third party, and we have deal with all the standardizations and all the testings for the battery energy storage systems. And today I make a consolidated table to see that in the world for different areas, what's the test standards for battery storage system. So for me, I will be focusing on the EU regulations and EU standards. And so we can see from the performance part, we have the 62620 for the battery pack and battery storage system itself, and 62933-2-1 mainly focusing on the on-site testing and performance evaluation for the battery energy storage system. So from safety-wide, we have 62619 and 63056, which describes the basic safety for the battery part. And we also have 62477-1 and 62040-1, mainly focusing on the PCS power conversion system of the battery. 62933-5-2 is quite important. Actually, it's the safety requirement for the energy storage system, and especially it covers all the aspects from design, from the type approval, from the factory acceptance test, which is kind of outgoing test before the product get out of the factory, and also describes how you could do the evaluations on site as site acceptance test. And in Germany, we have a special standard VDE 2510-50, which regulates the safety requirements in the German country. We have the EMC as well. We also have the transportations regulations and standards, which we test all the battery systems that goes on the road. We have the installation regulations in different countries that regulate how the battery energy storage system should be installed, and how and what qualified staff is allowed to deal with this kind of installation. For the functional safety, we have the general 60730-1 for the hardware evaluation and 61508 for the software evaluation. For the chemical part, we have the ROS and REACH regulation, and there's a new very hot topic for the battery regulation in Europe, which came in force January 1 year ago. There's also a big topic for the fire and explosion protection. That's where I make a separate table. And this is very important for the battery energy storage system because as we know that when you want to get something on fire, generally it needs three elements, which is oxygen, which is the fuel, and which is the heat. But for the energy storage system, they don't really need all the three things. You can only have the heat, and you can only have the fuel, which is the battery itself, because the battery is kind of energy source already, and it can get fire, it can get explosions without oxygen involvement. And that's also why it is really hard for the energy storage system when it start to get fire. It's really hard to put it down. So that's where there are a lot of regulations, a lot of standards could be considered and should be considered to validate and to test on, to make sure the battery energy storage system has a safeguard for the fire and explosions. So go back to the very first page where we talk about the potential hazards that energy storage could be. This is another categorized table, which we can see what tests can be done to evaluate, to validate the measures has been taken for different consideration of hazard. Just for example, for electrical hazard, we could do the short circuit protection test, insulation resistance test, impulse voltage, the electrical voltage, earthing, and others. For the mechanical, we could do the enclosure impact, static force. We also have the earthquake impact and vibration simulations, which we can validate if this design is good and has the mechanical strength enough. So here are also some other examples I take out. For example, the overcharge control of the voltage test, which simulate that the control system in the battery, in the BMS, is not functional and could cause an overcharge for the batteries and abnormal in the excessive in the voltage, and therefore could cause the a further explosion or further fire. So this is instruction from IEC 62619. The other example from the German standard VDE 2510-50 is insulation resistance test to simulate some electrical shock that could cause hazards to the people that touching it. One important aspect and example is extracted from 60730-1, which is the functional safety analyze. This is also quite important, and especially when the BMS manufacturers or the system integrator that use a BMS and use an EMS and all the other management systems. They must cooperate with each other that to make a good system integration level. And also that it is really, really recommended that not only the software part for the functional safety is analyzed, the hardware itself is also analyzed, because the BMS in the end is an electrical component or electrical board that controls the current flow. And we know the hardware or the electrical components has certain lifetime, and with longer use in the field, the failure rate will increase, and that's where we need to analyze such behavior on the hardware level as well. Okay, thanks. I will give the stage back to Hakeem.
Thanks again, Shimeng. So yeah, really, that's really helpful in understanding all these different requirements and regulations. And just to tag on to that, I'll try not to take too long here. As you can imagine, our test list is extensive, our certification list is extensive, but I was just putting out some key ones. So some of the electrical validation we do around the installation testing, a withstand test, grounding test, these are all done according to standards and requirements that have been developed by the industry, in line, trying to keep in line with making sure we're compliant with the different regulations. I guess for us as a manufacturer, I mentioned earlier, and I cannot overemphasize that the challenge for us is keeping up with the varying requirements across different countries, different regions. So having some way of standardizing these could be quite helpful in what we do and how we design for a better tomorrow. That was electrical. Mechanical verification. Again, one fault I identified earlier with the previous incident was an electrical issue that got carried over into the battery. I've talked about the mechanical side of things, which is if you don't design an enclosure that's weatherproof. And when I say weatherproof, it can withstand a significant adverse weather, and this is what we want. So we don't have a situation where there's a thunderstorm and then it breaks the enclosure and then there's a leak into the battery that causes a short circuit. Thermal verification or thermal runaway verification. This is do not the abuse testing. We conduct at different product levels or component levels to make sure we are not at risk of thermal runaway. So overcharging, overheating, drop test, over discharge, all of these different tests are things we do at various points. You think about UL 1973, for example, that Shimeng showed earlier on, and what happens there, what we tend to do is we want to put a normal cell or a normal sort of DUT, so device under test, into an abnormal condition that could realistically happen. So short circuit, dropping, what's going to happen? Does it spontaneously combust? We definitely don't want that. And then doing that test, confirming that it doesn't combust based on realistic abuse conditions it could face in real life. We then go on to a 9540A test, where the aim is to put that DUT into thermal runaway and then evaluate how it behaves going forward or during operation. And just to highlight that, I picked UL 9540 as one of the sort of product certifications we go through, and in essence, this is a test that sort of validates or looks at how thermal runaway could occur in the system, and if that propagates. The intention is to make sure this does not sort of propagate across the whole system. So we've done that unit level testing, which manufacturers have done, but I just wanted to also highlight how we've maybe gone above and beyond to an extent in terms of what is required. We only need to really do the unit level one according to several regulations, but we've gone above and done an installation level version. So I will just show a video now. It is quite loud, so please do turn down your volume.
实验已经准备完毕，请出开始。
Yeah, so I hope everyone sort of saw and heard that correctly. But again, that's just an indication. This is what we do. We try and go above and beyond where we can to evaluate. So when you do that type of testing, as you saw, our fire suppression system components, they all kicked in and behaved the way they were supposed to. So we triggered thermal runaway in a module, tried to see, understand, gases generated, how much heat is, as you can see, the cell temperatures in that module on the chart on the right. And, you have temperatures reaching 600 degrees C inside. So again, it's validated. Yes, it can happen if thermal runaway to happen, doesn't propagate, and our systems can put these events out accordingly. So yeah. I will move on to just cautious about time. I'll hand over to Shimeng now, who can just sort of talk about what a roadmap looks like for a successful ESS project.
Yes, thank you, Hakeem. So we talked about the product. Trina also introduced a very comprehensive product they made. And I would also like to take this opportunity to introduce about the project-wise, where the product is selected with a very good product. But then it's not only the product that could lead to a successful project of the energy storage system, but also that starting from the preliminary study, where the product is part of that, and also the investigation of the site and the feasibility study about putting a battery storage system in such an area. Is that good or not? And then about the overall design, not only the battery storage system itself, but also all the other balancing parts of the project site. And where you need technical consultancy about the contract, about the review of the operation and maintenance partners, about all the suppliers, about all the technical specifications that you needed, management in the supply chain to do the factory supervision of the production, lab testing to verify that the end product is the same as the type approval product. And also we have to take care of the construction technical supervisions. And after or before the commission of the battery storage system, we also need a final acceptance test on site to make sure the performance and the safety are all in compliance with the design. And of course, the batteries energy storage system is supposed to be used for years. So it is also important to have a great or good operation and maintenance guidance on that part. Another special topic, I also put it the categories in a slightly different way, which also want to emphasize on the end of life recycling for the battery storage systems, where the batteries should be recycled and should be reused for the materials that is as much as possible. So all these factors could lead to from our point of view, could lead to a successful ESS project. Okay, thank you all.
Yeah, right. So yeah, with that, I think thanks everyone. I'll hand over to Andy now. I think we're just about running out of time. But yes, this is Trina, and yeah, looking forward to any questions you might have, both now and at a later time, when I might run into some of you at different events through the year. Thank you.
That's fantastic. Thanks so much to our expert speakers, Hakeem and Shimeng. I'm sure Trina is, not a name that requires any introduction whatsoever for our solar PV readers. And, Trina Storage is becoming a very well-known name as well, but a little bit newer in the space. So, yeah, great to hear your views there, Hakeem and Shimeng. I think everyone in the audience also appreciated, the level of detail that obviously you and your team work to in considering the safety, the risk and hazard analysis around energy storage. So we have got time for a few questions, and I say we've got time for a few questions. We got lots of great questions in. Thank you so much. And do you know what? Don't be afraid to keep those questions coming into the audience. It's unlikely we'll be able to answer them now during the session, but you will be able to get those answered afterwards by Trina Storage and hopefully from TUV Nord as well. So diving straight into these, the first question I have from the audience is from Edward. Thank you very much for your question, Edward. And it's around an industry trend that I think we've been reporting on increasingly, and that is about increasing cell capacity. So, you've got large format cells here. It wasn't long ago that they were under 300 amp hours and they exceed that, and some cells are much bigger. So Edward asks, do increasing cell capacities pose any additional risk in terms of thermal management? And how do Trina or TUV Nord or both expect to solve issues such as thermal gradients across large format or larger format cells? I don't know if you want to take that one to start with, and if Shimeng's got some views, he's welcome to add some thoughts.
Thanks for that. So certainly an interesting question, and I think I've got a few questions like that from developers as well. Just trying to understand, pushing for energy content. Is that really the way? Just building bigger systems and having more energy, or do we manage and improve our efficiency? But in short, before I on a tangent. Yes, we have larger format cells now. They've grown significantly in the last couple of years. There is an impact to the thermal management system, but I think primarily it's more of how we use the system. So rather than the kilowatt hours or megawatt hours you've got in the system, is how many kilowatts or megawatts you're going to be drawing from the system that's going to have a material impact on the thermal management. As we use these systems more and as we develop them for bigger projects, develop bigger products, yes, the thermal management system will need to be more powerful. It could be the duty cycle, it could be the application. We will need to develop bigger thermal management system, which has its own challenges because, again, remember, these systems are pre-assembled, pre-built and shipped. In Europe especially, and in the UK, we have a big problem with weight. So weight's being an issue for us. We have to, it's almost like a balancing act. How do we do it? We want to make everything bigger, but we have limits on how to make everything, on how we can make everything bigger. So it's just having that consideration for it. So yes, it could lead to it, but I think it's more about, it could lead to bigger thermal management systems, but I think it's more about the application really. So think if we're still using systems that however many kilowatts we're drawing from it, however many megawatts we're drawing from it, that's what would really have the impact on the thermal management. I think that's one part. I feel like there's a second part to that question. I don't know if I've touched on it at all.
So one follow on from that is what the key features of Trina's equipment are at the cell level in terms of safety, and what are some of the improvements that Trina's made? So some people may not know that Trina does use in-house manufactured LFP cells.
Yeah.
Yeah.
And that's a big one for us at Trina. That's what we try to sell. It helps with supply chain issues. It helps with knowledge and know-how as well. When you have all of these systems done in-house and manufactured, we recently released a series of videos that showed sort of what we do internally. So exactly as you highlighted, the big one for Trina is we now manufacture ourselves. For us, maintaining, now I remember the second part of that question was, how do we maintain sort of thermal gradients? That's a very good question.
Right.
We don't have it perfectly, but we are making significant progress. And one thing that differentiates Trina from the rest of the market, within our modules, we have a thermal gradient profile of less than 2.5 degrees. So that's actually really big, because the bigger that gap is and the thermal gradient, the worse performance you're going to get out of your system, because you're going to have cells that are suffering or working more than the others, or facing the heat of the problem, pardon the pun, for doing the same work, and that limits your overall system performance. So for us, thermal gradients, big topic. It's always a work in progress for all designers, but for us, we've got to a level where we are less than 2.5 degrees in module, and that will promote better performing modules through the life of the product.
That's great. And Shimeng, I don't know if you have any views from TUV Nord around kind of large format cells and how you might assess, the risk analysis or hazard analysis differently within that.
Yeah, so we know the system is getting bigger and bigger, and also from risk management perspective, actually every hazard type is not a standalone thing. So when we have, for example, a fire hazard, you could always follow up with chemical problems, chemical leakage problems. You could have the explosion problem. And all the others. So when we do the design and when we think about the risk control of all these aspects, you should never only consider one part, but also all the connection parts that is linked with this. So from testing perspective, usually the standards is not ahead of the product, but always late that product. So the test method existing in the current standardization world may be slower than the development of the product itself. So this also requires the industry that to work together to develop the standard or to make sure the test methods is more and more advanced and more fitting to the new technologies that is happening in the market.
Okay, terrific, thanks. And we'll try and get through these fairly quickly, because we'll try and do a few more questions. But we had a couple of questions actually around a couple of the NFPA, so that's the National Fire Protection Association standards, and these are essentially North American standards, but often serve as a blueprint for best practices, if not standards, around the rest of the world. So one of the questions we had from Pavan, so thanks for your question, Pavan, was what's your view on NFPA 68, which is the explosion venting standard, and NFPA 69, which is explosion prevention and control, given NFPA 855, which is the overall standard for energy storage fire safety, excludes passive systems. And Pavan suggests that is combining active and passive approaches the safest way forward for BESS, with active systems reliant on electricity and maintenance. So a bit of a long question there, but I don't know if who wants to go with that one first, if you have a view.
Yeah, again, good question. Do you want the short answer or the long answer? That's I think that's the key quick question, but I will make it very short. I think you're right, Pavan. I think in the end we're gonna get to I always say a hybrid type system, because each version almost has its own limitation or its own risk. So NFPA 68, control of explosions through deflagration venting, and then 69 through breathing in effect, which is controlling the level of flammable gas you have in your system. I haven't seen any studies that have concluded one way is better than the other. I haven't seen that. All I know is we have different ways of doing it, which is why I highlighted earlier on. And this just again points to the fact that having a concise, a uniform standard we all work to is great if all the other regions are going to accept that. As you clearly mentioned, NFPA is an American standard, but it's actually used globally everywhere. It's sort of similar practices and similar rules that are being followed, even if they've been adopted into a slightly different place. So we will, I think, so this is my view, we'll end up in a place where we have a mix of all of these systems because they all have they all have pros and cons in essence. And there's no conclusive studies that say this is the way to go all of the time. So which is why, as an Elementor, we offer the deflagration panels as an option, because what we found out is, speaking to some customers or some AHJs, that's a firm requirement. It's not a firm requirement in some projects or in some regions. It's a firm requirement in others. So it's sort of trying to understand these differences and where they come in and be like, right, okay, is this a necessity? Are we doing it because of the regulation? Or is this going to make a material difference to the performance of our entire system? Sorry, that was still long, but just a quick answer.
No problem. No. I mean, I think these are important questions, and there's only so far you can kind of shorten that down if you want to give a proper answer. So appreciate that you gave a proper answer, Hakeem. No problem at all. Shimeng, any view on that, on the explosion prevention and venting standards at all?
Yeah, just a short confirmation about this statement that this UL or American standard is actually using universally also in Europe, because the IEC standard, which is generally from standardization point of view, is generally used in Europe mainly, where the American has the UL and the CSA standards. But actually in the IEC standards, it also refers to the American standards for this explosion fire protection part. So what this means is that this FPA standards is more advanced at the moment. That's where the people that the IEC board is also referring to that, and would be used as a reference that to validate this part.
Okay, absolutely. And we did have a few sort of specific questions on standards that maybe you can help us with, Shimeng, as well. So one was from Antti, so thank you for your question, Antti, who asked which of these test standards are compulsory in the European Union.
Okay, so I could.
Might be tricky to go through the whole list, so maybe if you want to give an illustrative description, or you can go back to this if you like.
Yeah, so I just bring back to the previous page, one page about the standardization for the energy storage systems, and I think it's on the screen now. So basically, we have two aspects to think about. One is the product itself for the battery storage systems, where actually in Europe, the only mandatory one is the last one, battery regulations that enforced from last year. But inside the battery regulations, it refers to a lot of different harmonized standards for different aspects of the battery. For example, the chemical part about REACH is included in battery regulation. The safety consideration is included. The performance is included. But the only thing is that because this regulation is quite new, so lots of the standards are not harmonized or not really agreed among different parties. So what has become from the different aspects of the battery is which is considered mandatory to be evaluated when you put the product in the European market. Safety, performance, chemical, also the carbon footprint is also a big topic. So that's, but the problem is that there's still under the harmonization process to decide what standard is good for what type of batteries, because in the regulation it has different, it categorizes different type of batteries. The portable batteries, the batteries used for automotive, the battery used for light traction and others. and also industrial batteries such as battery energy storage systems. The other aspect is considered is about the installation, which is mainly country specified. So as we see the installation part for these Germany, for Netherlands, for UK as well already, they have different installation requirements. So these are the two aspects we need to look into, and these are considered mandatory.
Okay, great. So on this next question, which again is around standards, but actually more about testing. Again, I don't know if this is something that can be summed up in a brief answer. So you might want to just sort of point people towards some resources where they can perhaps learn more. But Jose, thanks for your question, Jose, asks, what tests should be performed on a BESS to verify its correct installation and functionality? And is this determined by a standard? I guess it would be a set of standards, but so testing that performed on a BESS to verify correct installation and functionality, what do you think the best approach would be for that?
Maybe I could also answer that. So the IEC is setting up a series of standards, which IEC 62933 series. You can see from the performance part, we have IEC 62933-1, which actually is, I think the title of the standard is the performance of a battery energy storage system. So we also have the safety here. You can see from the safety section 6293-5-2 and all the other parts of the series of the standard. So this could be used as a reference where you want to evaluate the correct installation of the battery system, not only for the performance, but also safety and all the others. Yeah.
Excellent. Okay, thanks, Shimeng. And you know what, we had quite a few questions around strategies for fire suppression systems and specifically, I think, around water and some of the issues around that. We had quite a few questions. We're not going to be able to ask all of them by any means. And also, I think the video that we showed towards the end of the session, kind of piqued some interest in the audience. So really quick, easy question on that from Giovanni. Thanks for your question, Giovanni. For you, Hakeem, was the sprinkler system, was that used during the test?
Yes, it certainly was. It came on in the test after to ensure there was no reignition. I think your first point is that was very much expected. I think right now in our industry there is a massive discussion and debate about what's the best way to put out a fire in thermal runaway. Again, it's another topic. To my knowledge, there's no one way that we have a consensus on to say, yes, this is the way, this is what's going to work. So there will be people in the audience with different opinions, but what we've adopted at Trina is to try and be best in class from what we understand, and that is using the aerosol plus water. I actually did see a question come through earlier around why there's a risk, would water even be able to get to there, because firefighters are nervous about connecting up to the units if anything was to go wrong at the same time. But sadly, I don't have an answer to that. These are all questions. The only thing from my perspective that helps a lot is having some level of harmonization or uniformity with the different requirements, because they are different. The question around the batteries, what regulations do you have to follow? It's a set of regulations. There's no one, and it differs according to the different regions, even according to the different projects. To just give you as an example, you could be in Germany, for example, and your project, your requirements would be a mix of UL standards, IEC standards, VDS specific standards. So VDS being the German authority specific standards. And we as a manufacturer, I have to go read all of this and cater for all of that, which presents its own challenges in its own right, as you'd imagine, because now I have a customer in Germany, another customer in Spain, and I'm looking at, yes, there's a set of there's a Venn diagram of requirements that are the same, but then there's a bit on the other side that's very different, and trying to bring those together can be quite a challenge, because it's one product we're selling in essence. Obviously, aside from the variants, it's one product platform that we're selling.
Yeah, awesome. And I mean, we're running a little bit over time, but I kind of feel like the audience is still really engaged and still listening. So if it's okay with you guys, we're going to push on for a little bit longer and try and just do a couple more of these questions, I think, because seems like there's an appetite to have those answered. And just to reassure some of those that you have been asking, the session, just to emphasize, it is recorded. It will be available on the on-demand section of the website, and you will, if you've registered, which you have, you'll be sent a link to view that, and it can also be seen on the Energy Storage News YouTube channel. You just have to search on YouTube Energy Storage News, and our channel should come up straight away. So one other interesting question around the fire suppression from Sodik was around, so thanks for your question there, Sodik. Regarding if the water fire suppression sprinkler is more reliable than the other fire suppression system, which I assume is the aerosol. So let's leave that bit to one side, but they go on to ask, is that are they both built-in solutions, or do you have to choose one solution or the other, or both, depending on local rules and standards?
With regards to the water and the aerosol, it would be standard having those two. I don't know of any authority that would mandate us to either remove one or the other. But what I will say is there are some regions that don't, or some projects, I should say, because it might not be a region requirement, that don't need a water sprinkler system. Because again, alluding to the question I said I read earlier on, some authorities, they are more concerned that, look, we're not going to have any responders actually go and connect to these systems. We need to find some other sort of way. When I think about another project, for example, that we've looked at, what they tend to do is we're considering is having site specific water sprinkler system, so external to the to the enclosure. It's not internal, it's external, and they were happy with that arrangement over someone or a first responder going in and connecting up to these systems. Again, highlighting the various requirements. So to answer the question in short, both will come as standard, the connection port with the aerosol. If anything needs to change for whatever reason for a specific authority, we evaluate that on a case-by-case basis, and we can have that discussion.
Okay, terrific. I think last question now on the fire suppression equipment aspect. So as I say, lots of questions about that, but I think we're going to have to save those for another time. But Chris asks, and thanks for your question, Chris, says that aerosol suppression is known to interfere with gas sensor functionality. So how do you ensure that the NFPA 69 system activates if there is an aerosol release to ensure there is not an even greater risk of a deflagration event? And he asks whether you've performed a test in order to validate that.
So this is if we've performed a test to validate if the aerosol discharges, or?
So no, so Chris suggests that there's a possibility of aerosol suppression interfering with the functionality of gas sensors. And therefore, how do you ensure the NFPA 69 system activates if there is an aerosol release, and whether or not that potentially does interfere with the gas sensors and ensure that there's not a greater risk, therefore, of deflagration?
Yes. So in summary, sorry, I'm hearing some echo. In summary, I think Chris is just about right in the sense that yes, we have these systems installed, but as I mentioned earlier on, the lack of a consensus on what's best practice does make it difficult, because to make our system work the way it's supposed to, we design the BMS accordingly. So to mitigate or to work correctly, it has to do with the BMS timings of thresholds. So when is the aerosol discharged? How long is it going to be suspended in air? And when are the flammable gases going to be released? The problem highlighted by Chris is still there. It's always there. It's always a risk. So when I talked about earlier on about how the different protocols, either following NFPA 68, following NFPA 69, using deflagration, using breathing, using sparker systems, they all have their pros and cons. That was a con for the NFPA 69 routes that Chris mentioned. So the risk is there, but we're able to mitigate that through proper system design. So that's getting the timings correctly, understanding the profile, the discharge profile of the aerosol, understanding the residual behavior, and being able to align that to obviously the actuation of our exhaust system.
Excellent, excellent. And I think, yeah, just a couple more quick ones. Question from John. Thank you very much for your question, John. I note that you've asked two related questions, but I think I'm only going to go for your second one. So apologies for that, but that is very much based on time. John notes that competing lithium products seem to be judged almost solely on cost. So how do you balance the industry's drive or demand for low-cost lithium whilst also ensuring high product quality?
Tricky question. That's the biggest. That's true. You're absolutely right. And actually, personally, and this is my personal view. Yes, I think sometimes the pushing for cost, we have to be very careful with that, because do we want to take a penalty to any sort of performance you will be getting with the system? So I don't know if I have a direct answer to that question. All I can say is yes, cost is a big driving factor, because guess what? We want to sell a product, and developers, asset owners, they do the maths, they do the calculations to work out what they're willing to pay for what. In terms of balancing it out for us, we want to have a competitive, safe system. However much money it takes to build that, to design it properly according to the requirements, we will do that. I can't speak too much about the industrial driver for reduced cost. We're a manufacturer. We're gonna get asked to build stuff based on what the customers, the developers, the owners are saying. So it's a hard balance, but we try our best to do it. Priority for us is to make a safe, properly designed product. That's the priority for us.
Excellent. Well fielded, Hakeem. I think we put you on the spot with that almost philosophical question around commoditization, cost, and quality. So I'll give you one last opportunity to answer a nice easy one, I guess. And in fact, there's a couple of people asked this. So thanks for your questions, Victor and William, who are asking where Trina's battery storage systems and I guess the other components are built, and if you have worldwide service and availability.
Our systems are built completely in Changzhou, China. I think I showed that at the end. This is where we do our factory acceptance tests. This is where our consultants, customers, visits. So Chuzhou, not Changzhou. I made a mistake there. Chuzhou is where we build and do our factory acceptance tests, and customers are invited, consultants are invited to see. So it's all built there. It's not separate. We have our cell assembly line there. We have our enclosures built and shipped to there. We have the elemental built there, assembled, the modules all put into the cabinets, and final assembly done and shipped. So it happens in Chuzhou, in China. All of it happens in China and is shipped from China. In terms of coverage, we do have service coverage across different regions, but as you'd imagine, with any company, with a growing company, as we open more regions, get into more regions, our services and scopes are more limited than they are in other places. Right now, UK and Europe, we have a developed team to support the projects in this region. That's probably all I can say for now. As we gain more projects, more traction in the different regions, the service department would grow accordingly as well.
Excellent. Okay, so now we really do have to wrap up, I think. But it's been a great session, and always lovely to see that kind of lively back and forth discussion between the audience asking the questions and some great answers, both from Hakeem and Shimeng. And thanks so much for the benefit of your experience, guys. It's been a real pleasure working with you both and your teams. And yeah, I guess probably the most important thank you now comes to our audience who registered, watched, and interacted. So thank you so much. And on a personal note, from me, thank you so much to everyone that's involved in this great, exciting, game-changing industry. So with that, I'd like to wish you all the best and have a lovely evening, afternoon, or night, depending where you are. And we'll see you soon. Thank you very much.